Hello, Algebra 1 students, and welcome to Lesson 9.6 on the quadratic formula and the discriminant. In today's lesson, you are going to learn this quadratic formula, a universal way to solve any quadratic equation, as long as it's in standard form and you can identify an A, B, and C value. So this quadratic formula is very powerful, and you will need it if you take upper-level mathematics courses. All right, so let's take a look here. So on this slide, this is our first example. This is the quadratic formula. So let's break down the quadratic formula. So it says x equals, now some of this might look familiar to you, right? This is the opposite of b plus or minus the square root of b squared minus 4ac all over double A. So this opposite of b and double A, if you remember when we found the vertex using a in standard form, it's the same formula. Right? But we're just adding this plus or minus square root thing, and this is going to give us our solutions. Or I think we've talked about this, or your x-intercepts if graphing. All right. So first off, you need to make sure your equation fits this mold, right? Ax squared plus bx plus c equals 0, right? This equals 0, just like when we did factoring, is so important, right? So make sure it says equals 0. Once you have that, then you can identify a, b, and c, plug them in, and go. Now, a couple things about this formula. So first off, this plus or minus right here is important. That's what gives you your two solutions, right? So remember, typically, for these quadratics, you have two solutions because it's x squared, right? So because it's x squared, you have two solutions. And then secondly, I want to draw your attention to this square root. This thing inside the square root, the b squared minus 4ac, this is called the discriminant. D-I-S-C-R-I-M, discriminant. We're going to talk about this in the later slides in video 2. I'm going to call it capital D, but you'll see that when I use the quadratic formula, I like to focus on the discriminant first because, again, that's a pretty scary formula, and you'll never have to memorize it. It'll be given to you, but there's a lot of pieces and parts to put in, so I like to start with that b squared minus 4ac first. Okay, so let's use this quadratic formula to define the solutions to this quadratic equation, right? So the first thing is, notice it doesn't say equals 0. Right? We need to make this look like this. So I need to bring that 4x to the left-hand side. It's a positive 4x, so I'm going to subtract it on both sides. So if I put the left-hand side in standard form, x squared minus 4x minus 7 equals, and these cancel, and you get 0 on the right-hand side. Notice I did not combine like my x squared and my 4x. Again, they're not like terms. And now we have a standard form quadratic, x squared minus 4x minus 7. Now, if you try to factor this, right, if you try to use that x and, put negative 7 there, negative 4 here, there are no factors of 7 that would get you to negative 4. The only factors of 7 are 1 and 7, and they do not add or subtract to 4. So you cannot factor this. Factoring would not work. So a equals 1. There's no number in front of x squared. B equals negative 4, and C equals negative 7. So notice the signs come with the numbers. And now we're going to start with this quadratic formula. I'll put green, and I'll start with the discriminant. So again, the discriminant is b squared minus 4ac. That is going to be negative 4 squared. Notice I used parentheses, right? Very important. Minus 4 times your a value is 1, and your c value is negative 7. And this right here, we would plug into Desmos to get the answer. Right, whatever it comes out to be. This is 16. This comes out to be positive 28. 16 and positive 28 is 44. There's your discriminant. That's going to go inside the square roots. So now if I fill out the formula, so x equals the opposite of b. So I put my b value in there, right? The opposite's on the outside. There's my plus or minus the square root, and my discriminant goes in here, and that's going to be 44 all over double A. And if you remember from the topic 7, or topic 8, sorry, I'd put that in parentheses, double A. Okay, so now we're going to simplify. So this equals, so the opposite of negative 4 is positive 4, plus or minus your discriminant under the square root of 44, and then the denominator is 2. Next thing, I'm going to go back to green. Now we need to look at this discriminant, the 44. Can we simplify this radically? I don't know how much we've done this year. I don't think anything with simplifying radicals. So I'm going to do a quick example for you. You're not going to be perfect at this. It's just getting you used to it. I don't even know if SAVIS is going to make you do this. Okay? I know the state test would not make you do this. So 44 is here. So I'm going to break down 44 into all its prime numbers. Remember, the prime numbers are 2, 3, 5, 7, so on. So again, you might see that 4 and 11 make 44, and you can do that first too. But I'm going to do 2 and then 22 because I know 2 is prime. I know that 2 goes into 22 as well. 2 and 11. Again, 2 is prime, and now I know 11 is prime. So it's actually to your advantage to start with the primes because you know that one of them is always going to be prime. So I know that 44, or the square root of 44, is the square root of 2 times 11. Those two 2's can make a 2 squared, or a 4 if you want to write it like that. What's nice about square roots is that they cancel squareds. So this 2 squared, what happens is this square root is going to cancel that squared, and it's going to bring the 2 on the outside. So this 2 comes out of the square root. That 2 squared is now gone, and the 11 stays inside because it's not squared. There wasn't 2 11s. And there is square root of 44 in simplest radical form, 2 square root of 11. So again, that might be complicated for you. I get it. It's not a huge deal of Algebra 1. Again, Savis might ask you for it, and you can always ask for help. So this is 4 plus or minus 2 square root of 11 over 2. Okay. Now, the next step is, if you do pull out a number from that square root, like we did here, now we need to look at these 3 numbers and see if there's a common factor. 4, 2, and 2 can all be divided by 2. So divide each one of them by 2. So that's going to be 4 divided by 2, which is 2, plus or minus. Now, 2 divided by 2 is 1. They just cancel. You don't need that. The square root of 11 comes. And then 2 divided by 2 is, again, 1. You don't need to put 1 in the denominator. This is it. These, and I say these because of the plus or minus, these are your 2 solutions. You're saying, well, that's only one thing. It's one box. Well, yes, but you can break this apart into x being equal to 2 plus the square root of 11 and x being equal to 2 minus the square root of 11. You have 2 separate solutions. This would be your exact form answer. And I think Savis will accept the plus or minus notation, or it will accept them separated. You just have to put a comma between them. So now, what if the problem said rounded, right? And typically it's rounded to 2 decimals or the nearest hundredth. Well, we can take these 2 numbers and plug them in to Desmos. So 2 plus square root of 11, 2 minus square root of 11. So let's do that now. Okay, so let's go to Desmos. And for some reason, Desmos, I don't know why the toolbar is not coming to Desmos. So I'm going to do this in Desmos and then write it back here. Okay? So we're going to do 2 plus the square root of 11. And that would get you 5.31, and the 6 rounds 1 to a 2. So 5.32, and then 2 minus the square root of 11. And that'd be negative 1.3, and again, the 6th rounded to a 2. So 5.32 negative 1.32. So I'm going to come back here, and again, I'll make it big so you can see. So again, we were in the corner here, so x equals 2 plus the square root of 11, and that came out to be 5.32, I believe, and x equals 2 minus the square root of 11, and that was negative 1.32. So these, I think, are my 2 solutions. Let me just double check. Yeah, 5.3 and negative 1.32. Okay, so again, it went away. Sorry about that. So now, just to kind of connect this to the graph, because we did this when we factored. So if I have 5.32 and negative 1.32, these are my 2 x-intercepts. So if you have some place on the picture here on the slide, maybe off to the side. So on here, my 2 x-intercepts would be 5.3. So that's 1, 2, 3, 4, 5, and then 6, and then negative 1.32. So 5.3 is somewhere here between 5 and 6, and then negative 1.3 is somewhere over here between negative 1 and negative 2. I know this opens up, so then your parabola looks something like this, right? So this parabola, this equation has 2 x-intercepts, 2 solutions. And again, we got that by using this formula called the quadratic formula. All right, great. So it looks like we have a word problem coming up, and then we have more talk of the discriminant. All right, so stay tuned for video number 2.